Let's recall that power equals voltage times current, and voltage equals current times resistance. Suppose we have a light bulb that consumes 20 milliwatts when connected to a 10-volt voltage source. What is the resistance of the light bulb? What is its electrical conductance? We recommend that when solving any problem, you first identify all the known parameters and also those that the question is asking for. For this example, we know the power and the voltage, and the question is asking for the resistance and the conductance. Next, write the relevant equations. Power is voltage times current, as given by the power equation. From Ohm's law, we know that voltage is current times resistance. Lastly, we have that resistance is equal to 1 divided by conductance. In this example, we know power and voltage, so we can find the current from the power equation. Once we know the current, we can use Ohm's law to find the resistance and the conductance. We know you're eager to start plugging in numbers, but we strongly recommend that you first solve the equation for the parameters you want, and in the final stage, plug in those numbers. From the power equation, we want to find the current, so we write I equals P over V. From Ohm's law, we want to find the resistance, so we write R equals V over I. Replacing I in Ohm's law by the current from the power equation, we have R equals V divided by P over V equals V squared over P. Now we have our answer, so we plug in the numbers. Don't forget to include units in every calculation. R equals V squared over P equals 10 V squared divided by 20 milliwatts, which gives us an answer of 5 kiloohms. Finally, the conductance is simply the reciprocal of the resistance. We have G equals 1 over R, or 1 divided by 5 kiloohms. Simple math tells us that the conductance is 0.2 millisiemens. Examples are awesome to learn new topics, so let's dive into another fun one. Suppose you're asked to design a light bulb and you're given copper and a 20-volt battery to build it. Also suppose that you measure the resistance of copper and every millimeter is 5 ohms. If your power budget is 10 watts, what is the minimum length of copper you should use to build a light bulb? Again, first let's write the parameters we know and then the ones you're asked to find. We know voltage equals 5 volts, maximum power equals 10 watts since power budget is 10 watts, resistance per millimeter of copper is 5 ohms. We need to find minimum length that will yield a power consumption of 10 watts. Now we write the equations we may need. V equals I times R, and P equals V times I. We know P and V, so from the power equation we can find the current I. Then with I and V, we can find the minimum resistance of copper to satisfy the power budget. So we have R equals V squared divided by P. Now we are ready to plug in the number. R equals 20 volts squared divided by 10 watts equals 40 ohms. We know the resistance now, but the question is asking for the length of wire that will yield 40 ohms. Since 1 millimeter of wire gives 5 ohms, how many millimeters will give us 40 ohms? The easiest way to solve this problem is to write it using fractions and then solve for the unknown length. 1 millimeter divided by x millimeters equals 5 ohms divided by 40 ohms. Then x equals 40 times 1 millimeter divided by 5 ohms. So the minimum length is 8 millimeters. If you use anything more than 8 millimeters, then the resistance will be smaller, resulting in a higher current and a higher power consumption. Go ahead, try it. Let the length be 9 millimeters and solve for the power. You can work the example we just did backwards.